Our topic is energy. Energy is measured in joules. The formulas for energy are gravitational, spring, kinetic, work, and power.
While it is important to know the formulas and equations for energy, it's also important to know the law of conservation of energy, which states that energy can't be created nor destroyed. So therefore, if I drop this water bottle into this very messy bed, it goes from gravitational energy to gravitational and kinetic energy, lands on the bed and becomes spring energy, and then becomes at rest, only to dissipate into the universe. Physics.
In this problem, I launch a 0.43 kilogram soccer ball across the park. If I kick the ball with 1,000,000 joules of energy and the ball reaches a max height of 3 meters, what is the ball's velocity at the top of its arc? Okay, so at the top of its arc, the ball has both gravitational and kinetic energy. Because of the law of conservation of energy, I can set this equal to the 1,000,000 joules that I kicked the ball with. By using the formulas for gravitational and kinetic energy and plugging in the given numbers, we find that this soccer ball is traveling at 2,156.6 meters per second. In this problem, Joe chucks a 10 kilogram cantaloupe 238 meters into the air. What is the velocity of the cantaloupe right before it splats on the ground? At its max height, the cantaloupe's gravitational energy is 23,800 joules. Because of the law of conservation of energy, you can set this equal to the formula for kinetic energy. After plugging numbers in and solving, the velocity of the cantaloupe is 69 meters per second.
A frisbee, which is 175 grams, traveling at 17 meters per second, moves the dog's face 25 centimeters when the frisbee is caught by the dog. The question is, what was the average force exerted by the frisbee on the dog's face? Here we can use the kinetics energy equation because the frisbee is traveling. And then we can also put in the work equation because we're trying to find force. And we can set these two equal to each other because the law of conservation of energy. And then from here you just plug and chug. And then you just divide 0.25 on the right side and put it on the left. And from that, you get
A 60-kilogram McChicken is lifted by a rope a distance of 10 meters straight up at a constant speed. How much power is required to complete this task in 5 seconds? First thing we need is our power equation, which is force times change in x all over time. We know what our change in x is, which is 10, and we know our time is 5. To find the force, we have to look at a free body diagram. We know the force of tension is equal to the force of gravity. The force of gravity equals mass times gravity. Our mass is 60 kilograms and gravity is 10, which gives us Fg equals 600. So we can plug that in for our F. So we get 600 times 10 all over 5. This gives us 12,000 watts.